All right, guys, welcome to the second video in the gears.cpp this series. This is a Vulkan API discussion series, and we're diving into gears.cpp. First of all, I want to give a shout out to Sascha Willems. He is the author of the script that I'm using to learn Vulkan, and I'm literally going through all of his scripts to sort of learn Vulkan for myself, and I'm carrying you along the way with me. If you want to partake in the fun, definitely you're gonna have to get tutorial number 1, which is installing the Vulkan API on your Windows-based machine with a Vulkan capable GPU. And then tutorial number 13 is walking you through the process of installing all the examples, including this one, on that machine so that you could run the script. Now, just to refresh your memory in case you skipped the first video, this is basically what the script does. It basically generates a bunch of gears that are spinning, rotating in different directions, right? And you could zoom in, zoom out. It's a visual thing, pixels on the screen, colors on the screen. The objects are rotating. You could move and rotate the whole assembly yourself. You could zoom in or zoom out, whatever you want to do. So yeah, this is the second discussion of this script. All right, so the way how I tackled it was that I went to the prepare function, which is kind of like the guiding force of all the tasks for the script. So I already did the prepare vertices one, right? So I'm now naturally going into the second step in this thing, and that's the setupDescriptorSetLayout function, okay? So there, that is up here. So setupDescriptorSetLayout. Now, for setupDescriptorSetLayout is this right here, right? Anytime you see descriptor set in Vulkan, just know that you're basically trying to give access to specific memory objects on the hard drive, on the SSD or something, whether it's on that hard drive or what have you. But basically, you're trying to get Vulkan to have access to it. Now, there's a whole complicated thing about, obviously, eventually moving all this stuff over to the GPU memory and, having it live on the GPU memory and all that stuff. But just whenever you see descriptor set, just know that Vulkan is trying to access a memory object, okay? I have 3 free videos on my YouTube channel that discusses descriptor sets, right? 3 different videos. The first 2 is like on the whiteboard. It's like diagramming. It gives you descriptor set, descriptor pool, descriptor set layout, descriptor set layout binding. It's all diagrammed out. The last video, the third video, is using the descriptor set in Insight Graphics. So basically running Insight Graphics and then, seeing sort of how all these little variables and things and memory objects and stuff, how it plays out in the Insight Graphics system, right? Now, Insight Graphics is a tool from NVIDIA that allows you to basically investigate and see what's happening behind the scenes of all your graphics applications, right? In order for you to have that program, you have to have an NVIDIA GPU, right? Just so you know, because it's from Insight Graphics, it's from NVIDIA. It's proprietary to their GPU. Anyway, so descriptor set, we're dealing with memory, and we want to access it. Now, descriptor set layout, generally, it's 3 things that the descriptor set layout or that conversation is trying to accomplish. Number 1 is trying to declare what kind of memory is in this object. So we're setting up this descriptor set layout situation. Number 1 is what kind of memory is in there. So basically, what type of memory is in there, right? Number 2, it's saying what can access the memory on the graphics pipeline. So remember now, the graphics pipeline is sort of the holy grail of the Vulkan API. It is basically the pipeline that eventually reaches to your screen and to the pixels on your screen. So, sort of everything dances around this graphics pipeline, right? And you have to tell Vulkan that, hey, we have this uniform buffer here, but the only thing that can access this uniform buffer is the vertex stage. I don't know if you call it vertex stage, vertex buffer stage, shader stage, vertex, whatever you want to call it. But there's a graphics pipeline, and it's only this vertex piece of the graphics pipeline that has access to this piece of memory. And this piece of memory, of course, is uniform buffer, right? That's pretty much what we're trying to get to. And this graphics pipeline, it's related to, you know, different stages of the pipeline. Basically, you're trying to get to the create pipeline layout. So if you notice here, this is the closest, most granular piece of the binding piece, right? Set layout bindings. This is the closest thing to the actual memory that we're dealing with. So here, it's very close to the memory, and of course, it's telling you it's uniform buffer type and what can access it. Notice that from here, we go from here all the way down to here. We're kind of skipping through a bunch of stuff, but basically, we're trying to create a VK create pipeline layout, and that's basically saying, okay, this is the object. This is you know how we're gonna set up things, and we want to trigger this VK pipeline layout function. But in order to do that, we have to do a little work. You know the tempo of Vulkan already. The tempo of Vulkan is you type a lot of stuff, you create a lot of create info stuff, and you basically encapsulate all that information into a variable, and you pass that variable to another function, and then you create another variable and all that good stuff, right? It's like you're just cascading. You're typing stuff, you're creating stuff, you're creating variables, and then you pass that variable into another function that triggers something else, and it creates another handle, another variable, and you take that variable and you move it around. So it's the same thing here. All right, let's start from the get-go. So we have the set layout binding, this variable. All right. So in this variable set layout binding, we have an initial a helper function created by Sascha called Descriptor Set Layout Binding. And in this, if you go to definition, it's descriptor type, shader stage flags, binding, and then descriptor count is, I guess, automatically set to 1, right? It's automatically set to 1. So what is the type? The type, blah, 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 you know, Vulkan has to make it complex, but basically uniform buffer, right? It's of type uniform buffer, VK descriptor type uniform buffer. Of course, you could Google this, you could look at the spec and whatever. So the memory type is uniform buffer. We got that. The stage, right? Second thing. So this is the type. The stage that we're using is VK shader stage buffer bit. All right, it's a vertex stage, vertex buffer stage, however you want to call it. All right, so that's the stage that we're using. All right, and then the third variable is the binding. So it's a first binding 0, right? Which I assume it relates to this right here. It's a binding 0, binding 0, binding 0. Okay, vertex shader uniform buffer. Nice way of putting it. Wasn't me, but that's how we roll it. So we have the set layout binding. We have all of this guy here, and it basically encapsulates all of this, right? And of course, it's this function here. All right, and it's a VK descriptor set layout binding. That's the type, right? So we're not lying to you. It's actually what it's doing. It's just that, you know, Sascha has a way where he kind of wants to make things easy because he wants to make the code readable and stuff. So he doesn't want a bunch of lines and lines and lines of code. So this helper function here, you know, he uses these functions for all of the examples, right? So you could kind of, you know, he reuses them. So that makes sense, right? Because it's common to all of the different examples, right? Dealing with gears right now. All right, so we have our set layout bindings variable. All right, cool. Next thing that we got to do now is we're going to do the descriptor layout. So these are the bindings, and now we're doing the layout. So the layout has another helper function here. But basically, if you look at it, it's basically, you know, like we said, we create a variable here, and then we pass the variable to another function here, right? So this helper function now, it's descriptor set. it's descriptor layout that function variable that we're creating, but we have another helper function here. Let's just go to it. Okay, so we have a VK descriptor set layout binding, and then the binding count. All right, so the binding is basically this guy right here, right? Set layout bindings.data, and then the binding count is, I guess, the size of the set layout bindings. All right. Have at it as you will. Let's move on. So we create our set layout bindings variable here, and then we basically pass the data and the size of it to this descriptor set layout create info, right? And always look at the types too. So descriptor set layout create info. Okay, so now we have a descriptor layout variable. Cool. Let's move on. So what we're gonna do now is we're gonna fire off VK create descriptor set layout. So anytime you see something with VK, you know that it's like really we're in Vulkan now, or like, you know, we're doing some serious stuff with Vulkan, right? So we're firing off this function and we're bringing in the device, which is like just the normal device. You could go to definition, but we're not gonna do that right here. Descriptor set layout, right? So that's this variable right here. We're passing in that information. Remember, this information is basically, it has encapsulated in it this information here, right? Null pointer, I'm not going to get into that. And then basically we have a handle. So the handle that we have now is at descriptor set layout. All right? I know this is confusing, guys. I know. I'm with you. I didn't make these names, what have you. It is a little confusing, all kinds of. Anyway, so we have a handle at descriptor set layout that's associated with this VK create descriptor set layout thing. So we now have our descriptor set layout that Vulkan is aware of. We have, you know, it's a VK function that's actually using, you know, created this variable. So we know like it's serious stuff now. All right. So now we take this variable and again, we just pass it along to the pipeline layout create info. So if we go to this helper function, we'll see it basically just takes out a set layout, and then I guess it defaults to, it's just a count of one, right? Or does it even default to it? Because we still declared it here. But anyway, it accepts the layout right here, right? So it accepts the layout. So this is the layout it accepts. And I guess this might be the default value, I don't know. Right? But it accepts the layout here, right? Which was created from here, which was part of this, which included this. So we're all in this together, right? So this now, this now is this p pipeline layout create info variable, and then now we have another VK function create pipeline layout, and then we're passing again this variable. Of course, we have our device, logical device, all that stuff. You could always go to definition if you want, but I don't want to do it here. We pass in this variable. There's a null pointer. Always have to have a null pointer, just, you know, for good decoration. And then we have our new variable pipeline layout. All right. And that's pretty much it. I mean, it's not too hard. It's not too hard. But again, guys, just remember, we did all this work to basically tell Vulkan that, hey, there's a memory object that has a memory type of uniform buffer in it. The vertex stage can access it, and that's pretty much it, right? And we're putting it on the pipeline layout. So the graphics pipeline knows that, hey, you know, and the vertex stage, you have access to this uniform buffer, etc., right? That's how I see it, and I'm sticking to it. Love to hear what you guys have to say about it. But you know, we're basically getting Vulkan aware that there's a memory object, and that's what it's all about. Isn't too hard, not too difficult. But yeah, that's it. So I'm gonna stop here because I don't want to confuse you guys. But again, that's this guy here, right? And you know what I would suggest you guys do after you have installed this and have the examples on your machine. what I suggest you guys do, like comment out some stuff, or like change some stuff and see if it renders. You know, the greatest thing, the beautiful thing about graphics applications is that you know when it's wrong because it doesn't show what you. It either doesn't show anything, it crashes, or it shows something that you don't expect. So tinker with these things. Understand that this is the closest thing to the memory, and then we kind of step back and step back and step back. So closest thing, second closest thing. We fire off a Vulkan function. We put it. You know, the handle for the object that's created is this. This gets put into this guy here, and we drop that into this Vulkan function. We drop that into this Vulkan function, and that's it. And remember, that's the tempo of the Vulkan API. You create a bunch of stuff, a bunch of variables with a bunch of parameters and like information and stuff. You encapsulate it in a handle or in a variable. You drop the variable in a VK function of some sort. The VK function creates another handle. You take that handle and then you do some more stuff with it. You create another variable, and then you drop that variable into another VK function again, and then you create another handle, and then it keeps moving and it keeps moving and it keeps moving, right? So that's how you build the graphics pipeline, and you build all your descriptor sets and all your memory objects and everything, so that Vulkan knows what it's dealing with, right? Anytime you see descriptor set, just know you're dealing with memory objects, and you're trying to get Vulkan to know about it, and you're trying to tell Vulkan, this is what it is, this is how you access it, this is how you deal with it, this is the type of the memory, blah, 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 etc., etc. All right, guys, listen. Like and subscribe to the YouTube channel. If you want to join in on the fun, at the very minimum, tutorial number 1, tutorial number 13, I have links in the description below. Tell your friends. Let's get involved. Learn computer graphics. Tell your friends so that it's not just you working on it. You have your friends that could work with you on it. It's time well spent. Listen, it's fun playing video games, and you should play video games, but also take some time out to learn something about computer graphics, right? It's time well spent. Anything you learn in life, you could use later on in life. And let's get going, man. Let's 2024. Let's learn some computer graphics. It's the future. Many applications, not just in entertainment or video games. There are many other architecture, CGI graphics, all that stuff. Real estate, things like that. Even retail and stuff. Virtual reality, augmented reality. You know, we're actually learning the granular code. We're not learning an engine, right? That like kind of ready-made stuff that does it for you. You're actually learning the code itself, how to put a pixel on a screen. Once you know how to put a pixel on the screen, you could basically custom craft anything in the world that you want, right? And you're not beholden to any kind of engine or any kind of parameters or any kind of third-party tool. You could actually put the pixel yourself on the screen and make stuff happen as you dream it. So if you're artistically inclined, if you're a creative person, learn computer graphics. Yes, it's a journey. I've been learning this stuff now, putting some serious time into it. Took a break last year, but I'm back. All right, guys. Thank you. Like and subscribe. Tell your friends. Get the tutorials. Let's get going. Make sure it's a Windows computer. Make sure the GPU that you have that the Windows computer is on, the GPU that the system has can run Vulkan. You have to make sure of that, because if it doesn't run Vulkan, it's not Vulkan capable, then you're out of luck. But there you have it, guys. All right. Have a great day. Bye.